Lesson 10-3, Geometric Sequences and Series. Use geometric sequences, find sums of geometric series. Let's find a way to find a formula that relates the term with the term number. In our domain and range, remember this is the counting numbers, and our range is the sequence of geometric sequence. Let's do that in terms of the first term. A sub 1 is our first term. To get to the second term, it'll be a sub 1 times r. To get to the third term, it'll be a sub 1 r to the second power because you're timesing by another r. A sub 1 times by another r to the third. A sub 1 times by another r to the fourth. Now notice the pattern is the number of r's is one less than the term number. So this term will be a sub 1 r to the n minus 1, and that's our formula right here. This relates the term number with the term. Let's go ahead and use this in this formula. We would like to find the sixth term, and that means taking the first term and timesing it by the common ratio to the 6 minus 1. That'll be -3 times -2 to the fifth power. And when we put that in the calculator, that'll be -3 times -2 to the fifth power. And that answer will be positive 96. Now remember the common ratio was negative, so the terms were going negative, positive, and so on. So it just happened that we started with, we had a positive number at that term number. Your turn, and here's the answer. Let's go ahead and find an equation for the nth term like we did with arithmetic. So here is the formula. We want to find a formula for the nth term. We use the first term, which is 5, and then let's notice what our ratio is. We're timesing by 2 each time, so our common ratio is a 2. So this will be 2 to the n minus 1. And this is our formula. Please do not multiply 5 times 2 because this is the exponential, and that has to go first, and then multiplying goes second. Okay, let's go ahead and do this again. We're going to write the equation. Unfortunately, we don't have the a sub 1 term, which the equation needs, so we're going to use this equation twice. Once to get the first term. So 4 equals a sub 1, and then we're taking it 3 to the 5 minus 1. So this is going to be a sub 1 to the, a sub 1 equals 4 over 3 to the fourth power, which happens to be 81. So now that we know what the first term is, we can write the equation for the nth term. A sub n is equal to 4 over 81 times, and our common ratio is 3 to the n minus 1. And again, remember, this is the exponential. That goes first before you multiply by the initial. Your turn. Here's the answer. Your turn. Here's the answer. All right, let's try to find the geometric means. These are terms that are between two non-consecutive terms. So we're wanting to find these, which means we need to know what the common ratio is. So we know this is the first term, and we know this is the fifth term. So let's go ahead and use that. So our fifth term is 49.92. Our first term is 3.12. And we're going to take r to the, and this is going to be 5 minus 1. So we're going to do 49.92 divided by 3.12 equals r to the fourth. And now we're going to take the fourth root on both sides. But whenever you take an even root, don't forget it's plus or minus. And when we put that in the calculator, the answer is going to be 2. Plus or minus 2. If it's plus 2, it'll be 3.12, and then double it, 6.24, double it, that'll be 12.48, double it, that'll be 24.96, double it, 49.92. Now, if we times by -2, this will we could take our first term, times it by negative. This will be a negative, and then timesing by -2 will be a positive, and times it by a negative will be -4.96, and then 49.92. So there's really two answers. You can have these three as your middle, or you can have these three as your middle. Pause to do the problem. Here's the answer. Now let's take a look at geometric series where we find the sum of the terms of the geometric sequence. And again, the partial sum is S of n. So you're finding the sum up to a certain number. There are two formulas, one where you know the first term and the number of terms, or if you know the first term and the last term. So let's go ahead and take a look at this. In this situation, I know the first term and I know the last term. So this is a perfect scenario for this formula right here. So our sum, and I don't really know how many terms there are in there, and I really don't need to know how many because my first term is 4 minus my last term is 1/16, and I've got to figure out what my r is, and it looks like I am multiplying by a half each time. So I'm going to put 1/2 in here, and then I'm going to put 1 minus 1/2. So this is going to be 4, take away 1 over 32, all over 1/2. And we're going to put that in our calculator. Don't forget to put parentheses around your numerator. And the answer is 7.9375. And if you change that into a fraction, that fraction is 127 over 16. All right, let's take a look at another one. And here I have the first term, I have the common ratio, and I have the sum. I want the sum to the 7 terms. So in this one, really, this one is going to serve me better because I don't know the last term. So the sum of the first 7 terms will be the first term, which is -3, minus a -3, and then the ratio is -2, and we know we're going to the 7th power, all divided by 1, take away, and then we have a -2 right here. So be careful with all these negative symbols, okay? So this will be -3, and I know this is going to be, I'm going to have 7 negative numbers here, another negative, and another negative. So that's going to be an odd number. So this is going to be minus, and that's going to be 3. And that number is going to be 384, all divided by +3. So I'm going to then add the two numbers in the numerator and divide by the denominator. And remember, I have to get a negative number, so this is going to be 129. All right, let's take a look at sigma notation. And in sigma notation, it's a shortcut into what the geometric series looks like. Now, when n is equal to 1, putting a 1 in here makes this exponent a 0. So this is 2 to the 0. So our first term is 3 plus, and then the next term will be 3 times 2, and the next will be 3 times 2 to the 2nd, and so on until we get to the last one, which is 2, and when we put a 12 in here, that's going to be to the 11th power. So we can use either one will work. I guess we could use the last one where we have the first term and the last term. So the sum will be equal to, the first term is 3 minus the last term is 3 times 2 to the 11th, and then we're going to multiply by the ratio, and the ratio is right here. It's 2 all over 1 minus 2. And so this is going to be 3, take away 3 times 2 to the 12th, all over -1. And we're going to go ahead and put that in our calculator. And that's going, don't forget your parentheses. And our answer is going to be pretty big, 12,285. Your turn. And here's the answer. Okay, we want to find a sub 1 in this geometric series for which we know the sum, and we know the number of terms, and we know the ratio. So it looks to me like this is going to be a good candidate right here. So we're going to have 765 equals, we don't know our first term, a sub 1, minus a sub 1. We know our r is 2, and we know we're taking it to the 8th power, all over 1 minus 2, because that's our ratio here. So this is going to be 765, and I'm going to factor out at a sub 1, and that's going to be 1 take away 2 to the 8th power, all over negative 1. So this is going to be negative 765 divided by 1 minus 2 to the 8th, and that's going to be our first term. So we're going to put that in our calculator. Don't forget to put parentheses around your denominator. And our first term will be equal to 3. Okay, your turn. And here's the answer.